Hello students, welcome back to EdUp. This is Ranjan from team EdUp. Dear students, this is second part of 7th lecture, and in the first part of 7th lecture I told you the concept of superposition theorem and how to apply the superposition theorem when a network is consisting of number of independent sources. Okay, now in this lecture we will be solving some more MCQs related to that concept, and we will see what kinds of questions can be framed from this concept in your upcoming SSC exam. So this lecture will be very interesting for you, and one sincere request to all, please watch all the lecture and don't skip any questions. Okay, all questions are equally important for your upcoming exam. Okay, so let's start today's lecture. Here in this question there are two independent sources, that is 10 ampere current source and one is 5 ampere current source. Now here we are going to solve this network by using your superposition theorem. Okay, as there are multiple sources, multiple independent sources. Okay, so let's consider the 10 ampere source is present alone. Okay, and removing this 5 ampere source. Okay, and I told you the 5 ampere source, that is your current source, can be opened by just opening this branch. Okay, this branch. So let me redraw the circuit. Here the current ampere source, that is 10 ampere, and here this is 2 ohm resistance, and here this is 1 ohm resistance, and this is your 4 ohm, and this is open circuited, and this is your 4 ohm. Okay, we have to tell here what is the voltage across this 1 ohm resistance. This is your V1. Okay, so we have to tell this V1. Okay, so here two resistances each of 4 ohm are connected in parallel, so their equivalent will be how much? This is 4 by 2, so 2. So these two, so their equivalent will be look like this. Okay, this is 2. Now these two and that 2 are connected in series, so the total resistance will be your 4. This is 2, this is 2, so 4. So let me again redraw the circuit so that everything will be very clear to you. This is 1 and this is your 2 plus 2, that is your 4. Okay, so this is 4 and this is your 1 ohm, and this is your 10 ampere. So here we have to tell what is the voltage across this 1 ohm resistance, that is your plus minus V1. Let's make this as V11, that is the voltage across this 1 ohm resistance due to this 10 ampere source, that is first source. Okay, V11. So now let's find the current flows through this 1 ohm resistance by using your current division rule. So we can write I11, let's say the current flows through this 1 ohm resistance equal to your 10 into here 4. Okay, 4 divided by 4 plus 1. Okay, this resistance is 4 and this resistance is 1. So this is how much? This is your 2 into 4. This is 8 ampere. Now the voltage V11 will be equal to your current into resistance. Current is 8 and your impedance or resistance is 1. So equal to your 8 volt. Okay. So due to the source 1, that is 10 ampere, the voltage will be your 8 volt. Now consider the 5 ampere source alone. Okay, by removing this 10 ampere source. Now let me redraw the circuit. So by opening this 10 ampere, here there is only 1 ohm resistance and we have to tell this V1 voltage. Okay, and here this is a resistance 2 ohm and this is a 4 ohm resistance and this is a current source and this is a resistance of 4 ohm and this is 5 ampere. Okay, so here 4 ohm and here 4 ohm are connected in parallel. Why? No, because they are connected across two same point, this one. So their equivalent will be 4 by 2 equal to 2. Okay, so this is 2. Now let me redraw the circuit. Here 1 ohm resistance and 2 ohm resistance, and here the equivalent resistances of this 4 ohm is equal to 2 ohm. Okay, and this is a current source of 5 ampere magnitude, and we have to calculate what is the voltage across this 1 ohm resistance, V1. Let's make this to be your V12, that is voltage across this 1 ohm resistance due to your second current source. So V12 we have to tell. Here the current flowing through this branch is your 5 ampere. Okay, now this current can be divided into these two paths. Okay, so now let's apply the current division rule to calculate the current flowing through this 1 ohm resistance. Okay, here the current flowing through this 1 ohm resistance is like this. Okay, from this terminal to this terminal. So this terminal will be your positive and this terminal will be your negative. Okay, this is very obvious. Okay, from basic concept. So now the current flows through this 1 ohm resistance is your I12. Okay, by applying the current division rule, here 5 into, here this is 2. Okay, this resistance, this branch resistance, divided by the total sum of resistance, that is your current division rule. Okay, so 2 plus 1 plus 2, this is 3. So this is 5 get cancelled out, so this is 2 ampere. Okay, here the voltage V12 equal to, here the current into its resistance, here current is 2 into resistance is 1. Okay, equal to 2 volt. Okay, if you take a close look here, the voltage polarity is your negative and positive. Okay, so here the polarity of this voltage V12 will take a negative sign. Okay, so this is equal to your minus 2 volt. Okay, and here the polarity of V11 is your 8 volt, that is your positive, here positive to negative, so this is positive. So the total voltage as per your superposition law, so V1 equal to V11 plus V12. Okay, so this is 8 minus 2 equal to 6 volt. Okay, so voltage across this 1 ohm resistance will be equal to your 6 volt. So your option C is your right answer. Now let's move on to the next question. Here in this question we have been given with a network, okay, where there are two sources, one is current source and other one is voltage source, and we have been given with a condition when the voltage source equal to 0, the current flows through this 30 ohm resistance is your 3 ampere. Okay, and when the voltage Vs equal to 200, we need to find what is the value of this current I flows through this 30 ohm resistance. Okay, so in the first condition, the voltage source is not there, means the voltage source equal to 0. So the response due to this current source alone is equal to your 3 ampere. So let make this as your I1. Okay, the response due to the source 1, that is your current source. Let's say I1 equal to your 3 ampere. It is given in the question itself. Okay, now when there is only voltage source, that is 200, okay, and we have to remove this current source. Okay, that is the application of superposition theorem. Okay, now let's open this source to calculate the response for this voltage source alone. So now let's redraw the circuit by removing this current source Is. We can write, so this is your open circuit. Here this is a resistance of 20 ohm and this is 30 ohm, and this is a voltage source, this one positive, this one negative. like that. Okay, so here I is flowing like this. Here the Vs is given to be your 200. Okay, here it is given 200 volt. So here in this circuit, the voltage source, that is the current supplied by this voltage source, will be like this. Okay, why? Now because this voltage source has, this one is positive and this one is negative, so it is very obvious that the current will be flowing like this. Okay, in this direction. So the net current supplied by this voltage source equal to I equal to your total voltage, this is 200 divided by total resistance, this is 20 plus 30 equal to 50 ohm. So this is 4 ampere. Okay, here in this question the current direction is given to be your downward. Okay, but here the current flowing through this 30 ohm resistance due to the source, voltage source, is upward. So the response due to this voltage source, let's say I2 current, equal to your minus 4 ampere. Okay, why? Now because this I value is downward and it supply the current upward, so I2 equal to your minus 4. Okay, now let's apply the superposition theorem, that is the net current flows through this 30 ohm resistance is equal to I equal to the individual response, that is the current flows through this 30 ohm resistance due to the current source plus the current flows through this 30 ohm resistance due to this voltage source Vs. So I1 plus I2. Okay, this is 3 and this is minus 4, so this is minus 1 ampere. Okay, the current flows through this 30 ohm resistance will be your equal to minus 1 ampere. So your option B is your right answer. Now let's move on to the next question. In this question, VI relation, that is voltage current relation for the network, this network is given to be your V equal to 4I minus 9. Now a resistance of magnitude R equal to 2 ohm is connected across it. Okay, like this. Now we have to tell what is the value of I, the current flowing through this resistance. Okay, here the voltage equal to 4I minus 9 is given. Okay, for this network. Here for this resistance we know the voltage across the resistance is V and the current flows through this resistance is your I. So by using Ohm's law we can write the total voltage equal to the resistance into its current. So this is 2 into I. Now use this voltage in this equation, we can write 2I equal to 4I minus 9. So by solving this, 2I equal to 9 implies that I equal to your 9 by 2 equal to 4.5 ampere. So current flowing through this 2 ohm resistance is your 4.5 ampere. So your option D is your right answer. Now let's move on to the next question. Here in this question we have been given with a network, that is linear resistive network, where there are two sources, one is voltage source and other one is current source. Okay, so these two sources are your excitation. Okay, now we have to tell what is the value of IL, that is the response, in term of your Vs and Is. Okay, and also we have been given with a table, that is your condition, for different value of Vs, Is, what will be your IL. Okay, so now let's apply superposition theorem. As I know that from superposition theorem the output or the response can be expressed as a linear combination of excitation. So let's write down IL equal to A into Vs plus B into Is, where A and B are two constant. Okay, we are using these two constant in order to express the linear combination. Okay, so this equation is based on the superposition theorem. Now using this table we can write here IL equal to 2. Okay, 2 ampere is given here, equal to A into 14 plus B into 6. Let's make this as equation 1. Similarly 6 equal to here a into 18 plus b into 2. Okay, let's make this as equation 2. So by solving this equation we can get a equal to your 0.4 and b equal to your minus 0.6. Okay, now put this value here in IL equation. We can write IL to be equal to your 0.5 Vs minus 0.6 Is. Okay, so looking to the option, your option D is your right answer. This is all about today's lecture. Here in this lecture we have discussed what is superposition theorem and how to solve a network by using superposition theorem when the network is consisting of number of independent sources. Okay, also we have discussed what kinds of questions can be framed from this chapter in your SSC JE exam. So one sincere request to all, watch this lecture and practice lot of questions. Okay, don't skip any questions from this lecture. All questions are equally important from your SSC exam point of view. So all the best for your upcoming exam. Okay, and in the next lecture we will be studying the next theorem, that is your Thevenin theorem and Norton theorem, and also we will solve some MCQs related to that theorem. Okay, by this let's wind up today's lecture. Thanks for watching everybody. See you in my next video. Till then, keep watching and keep learning. And one more thing, please subscribe to our channel and like the video. And if you have any doubt, then put your doubt in the comment section. Thank you.